This video is about the power rule for derivatives. We know x to the nth power. When we do the derivative, you will get n times x to the n minus 1th power. So basically, we drop down the exponents and then make the exponents reduced by 1. So let's practice some questions. We have x to the 7th power. See, we drop down this 7. Then x to 7 minus 1 is 6. X to the 3rd power. You will get 3 drop down. Then x, you do the 2nd power. 3 minus 1 is 2. When you do x squared derivative, you will get the 2x to the 1st power. That is 2x. When we have x, you will get, here's 1. So 1 times x to the 0 power. Any number to the 0 power is 1. Therefore, the derivative of x equals 1. It makes a lot of sense because for the derivative, we know it's about gradient of a tangent line. For linear function, every single point on the linear function, that graph has the same gradient, has the same slope. That's the reason for all linear function, the derivative will be the slope. If we have ax plus b, the derivative will be a. And if we have 1, what's the derivative for 1? For this 1, I can write down 1 times x to the 0 power. Then we do the derivative using this power rule. You will get 1 times 0 drop down, and then it's 0 minus 1 is negative 1. Any number multiplied by 0, you will get 0. Therefore, for constant number, let me write down C. Your derivative will be 0. What about the negative exponents? If we have x to the negative 1st power, we want to get the derivative for this. So negative 1 we drop down, then x. Negative 1 minus 1, that's negative 2. Since negative exponents cannot be the final answer, so we simplify. We drop this x to the negative 2 to the denominator. You will get the negative 1 over x squared. We know the negative exponents rule. If we have x to the negative nth power, we can get 1 over x to the nth power. We can do the backward. 1 over x to the nth power. That means x to the negative nth power. We call this is a single power form. When we're looking for 1 over x to the nth power, that derivative, you have to change into x to the negative nth power. Then you can use this power rule so that you can get negative n drop down. Then it's x to the negative n minus 1. So you simplify, you will get the negative n over x to the n plus 1th power. Therefore, when we're looking for the derivative of 1 over 6th power, the first step, you need to change into single power form. That is x to the negative 6th power. Then you can use the power rule. That will be negative 6 times x to the negative 7th power. Then you simplify, you will get the negative 6 x to the 7th power. These negative exponents cannot be the final answer. You have to change into positive exponents like this. What if we have a coefficient before x to the nth power? When we do the derivative for this, the coefficient stay. Then it's drop down this exponents n, then reduce by 1. So when you're working on the power rule of derivative, you need to figure out the coefficient. Let's go to some more examples. For a, y equals negative x to the 4th power, but we got to use this notation for derivative. Gradient function, that means derivative function. So we have dy by dx equals, the coefficient is negative 1. Then you drop down this 4, x to the 3rd power. Therefore, we got negative 4x to the 3rd power. For b, first of all, you need to change into single power form. That is 2 times x to the negative 4th power. We know this is the rule for derivative. You will get the a coefficient stay and n times x to the n minus 1th power. Then remember the derivative for x, that is 1. For constant number, say that is 0. Therefore, for dy by dx, coefficient is 2 times negative 4. Drop down, then it's minus 1, that's x to the negative 5th power. So we organize negative 8. X to the negative 5th power, I need to change into positive exponents, that's x to the 5th power. Let's go to say. For say, it's you have to change into single power first. So 1 over 6 x to the negative 5th power. Then you get dy by dx equals 1 over 6 times negative 5. Then x to the negative 5 minus 1, that's negative 6. So you get, this is over 1. So we get negative 5 over 6. X to the 6th power go to denominator. Then let's go to E. We have dy by dx. But make sure you change this into single power. So we have coefficient is negative 3 over 2, x to the negative 6th power. So you have negative 3 over 2 stay. Then drop down the negative exponents here. Then minus 1, that's negative 7. Therefore, we can reduce denominator and numerator. So you get negative 3 here. Negative 3 times negative 3 is 9. This one, negative exponents, you have to change into positive exponents. So you make it a denominator. This will be the